various arc control type oil circuit breaker. So there are mainly two types of arc control type oil circuit breaker. One is self blast oil circuit breaker and another one is the forced blast oil circuit breaker. In this there are three types. One is plain explosion pot, second is cross jet explosion pot, and third is self compensated explosion pot. So these are types of arc control type oil circuit breaker. Explain construction of plain explosion pot oil circuit breaker with figure. So in the figure you can visualize the plain explosion pot oil circuit breaker, one of the simplest construction of the oil circuit breaker. A strong steel tank filled with transformer oil which acts as both arc quenching medium as well as insulating medium is filled. In this type of circuit breaker, the fixed contact and moving contacts are kept in a closed shell of insulating material. The contacts are made up of copper or copper alloy. Explosion pot or the arc chamber is a cylindrical insulating enclosure. This is the insulating enclosure, often made up of porcelain or bakelite material surrounding the fixed contacts. This is surrounding the fixed contacts. The pot is open at the bottom of the chamber to allow the circulation of the oil and gas. Now, a mechanical linkage, that is operating mechanism, connects the moving contact to an external tripping mechanism, that is either manual or automatic via relay. This moving contact is in the form of rod which passes through the throat. Passes through this throat. Arc is produced across the contacts when the contacts are separated at the time of fault from the moving contact separates from the fixed contact at the time of fault. Now this causes the very huge amount of heat production, and due to this oil decomposition takes place due to the heat of the arc produced. So the gases are produced mainly hydrogen, ethane, methane, ethylene, etc. This high pressure is developed as the size of the chamber is very small. This arc is produced in this small chamber, hence the pressure developed by the arc is very high. Arcing horns or the arc control devices are also connected, that are optional devices to guide and control the arc inside the pot. This is the plain explosion pot. So this is how the plain explosion pot oil circuit breaker can be constructed. Explain working of plain explosion pot oil circuit breaker. So, plain explosion oil circuit breaker works very simply. Arc is produced across the contacts when the contacts are separated. Means the moving contacts are separated from the fixed contact at the time of fault, which causes the arc, and this arc is struck between these two contacts, decomposes the oil due to the heat produced of the arc. So, the gases are produced. High pressure is developed as the size of the chamber is small. In other words, the arc vaporizes surrounding oil, creating high pressure hydrogen gas inside the pot. The pressure forces the oil and gas through the arc, which cools and extinguishes it at current zero interval. If the moving contact is still in the chamber and the arc is not quenched, then when the moving contact comes out of the chamber from the bottom of the part, the arc is quenched due to the axial rush of the gas coming out of the throat. In this, the arc is quenched axially. So such type of oil circuit breaker is termed as or called as the axially extinction pot also. So this is how the working of plain explosion pot oil circuit breaker can be explained. Advantages of plain explosion pot oil circuit breaker. So there are several advantages of this type of breaker. The constructional design is simple, makes it easy to manufacture and maintain. No external compressor or mechanical oil pump is required for the arc extinction. Due to the simple construction and self-blast operation, it is low in cost compared to forced blast types. The explosion pot confines the arc within a small volume, improving the arc control and reducing the required oil quantity, making the breaker more compact and reliable. It is effective for medium voltage system, that is 33 kV or 66 kV system. only a small portion of oil participates in arc quenching, the total oil volume required is less. The high pressure gas is generated inside the pot and deionizes the arc path quickly, ensuring the rapid arc extinction. The self-contained arc chamber design reduces the oil contamination and carbonization, leading to the longer maintenance intervals. So these are several advantages of plain explosion pot oil circuit. Explain disadvantages of plain explosion pot oil circuit breaker. So there are several disadvantages of this type of breakers. Some of are like its uses are limited to medium voltage applications due to the unable to generate enough pressure for effective arc extinction. The effectiveness of extinction depends on the magnitude of the fault current, means for low fault currents the pressure may be insufficient. If the arc energy is excessive gas pressure may build up inside the pot, possibly damaging it or bursting it. The interruption process can be slower than in externally forced blast types of oil circuit breakers. The intense arcing causes oil decomposition and carbon deposits, which deteriorate the insulating properties of the oil over the time. The oil needs regular checking and replacement after interruptions to maintain insulation and cooling efficiency. Since oil is flammable, risk of the fire or explosion exists if the breaker is not properly maintained or if the internal pressure exceeds limits. Bulkier and requires more space than modern vacuum or SF6 types of circuit breakers. So these are several limitations of plain explosion pot oil circuit breaker. Explain construction of cross-jet explosion pot oil circuit breaker with feeder. So this type of circuit breaker is the modification of plain explosion pot oil circuit breaker. A strong steel tank filled with the transformer oil which acts as quenching medium as well as insulating medium is there. In this type of circuit breaker, the fixed and moving contacts are kept in a closed shell of insulating material, and these contacts are made up of copper or copper alloy. This construction is similar to the plain explosion pot type construction, but now the modification is with the arc chamber, a closed insulating chamber made up of porcelain or bakelite, enclosing the fixed contact. There is a channel on one side of the chamber which is known as the arc splitters. Here, it is arc splitters. Arc splitters help to increase the length of the arc. Cross-jet nozzles are small holes or ducts arranged at the right angle. Here, it is arranged at the right angle, 90 degrees to this. That is crosswise to the arc part. A mechanical linkage or operating mechanism connected with the moving contacts to an external tripping mechanism. This mechanism is operated manually or via automatically with the help of wheels. This is the construction details of cross-jet explosion pot oil circuit breaker. Explain working of cross-jet explosion pot oil circuit breaker. So the fixed and moving contacts are closed during the normal, that is closed condition, and the circuit carries the normal rated load current at that time. Now when a fault, that is short circuit or overload occurs, the protective relay operates and sends the trip signal to the breaker due to the rise in the value of the current. The operating mechanism moves the moving contact away from the fixed contact, so the moving contact moves away from the fixed contact, thereby opening the circuit. Now as the contacts separate, an arc is formed between them, and inside the explosion pot, that is in the arc chamber which is filled with the oil, the intense heat produced of the arc causes the surrounding oil to vaporize, producing hydrogen gas and oil vapors. This increases the pressure inside the explosion pot, but in the cross-jet type, external pressure also plays a major role in this. Simultaneously, the movement of the contact operates a piston or oil pump mechanism connected to it. This piston forces oil at the high pressure through the cross-jet nozzles, the arc splitters, and between them there is nozzle. This nozzle forces the fresh oil inside the arc chamber. These nozzles are perpendicular to this arc path. This arc path is like this. moving contact separates from the fixed contact, so the arc struck between this. So arc path is like this, and the cross jets from the nozzle fresh oil flows like this, which is exactly perpendicular to it, that is crosswise to the arc path. This is resulting high velocity oil jets blow across the arc, forming a cross jet blast. When moving contact crosses the first arc splitter, fresh oil tries to go inside or moving across the arc, so there is increase in the length of the arc. Similarly, the length of the arc increases due to the second arc splitter also. The cross-flowing oil jet sweeps away ionized gases around the arc, cools the arc column rapidly, and increases the dielectric strength of the medium or deionization of the arc path. As the dielectric strength between the contacts rapidly increases, the arc becomes unstable and extinguishes at the next current zero interval. So this is how the cross-jet explosion pot oil circuit breaker works. Explain advantages of cross-jet explosion pot oil circuit breaker. So this type of circuit breaker is called cross-jet explosion pot because pressure of the oil and gas acts in the transverse, that is, the arc path is like this, and the oil and gas pressure acts in this direction, that is transverse, that is crosswise direction, increasing the cooling and deionizing effect. This leads to faster and more effective arc extinction. Since the arc is confined to a small explosion pot and quenching action is more efficient than the plain break oil circuit breaker, the oil required for the arc extinction is less. The design allows the breaker to interrupt larger fault currents due to the strong blast of gas driven across the arc path. The arc is confined within the pot, so the main tank oil remains relatively unaffected. This reduces carbon formation and prolongs the oil life. The mechanical design and pressure jet help achieve quick arc extinction, allowing faster operation. Now, because of the effective cooling and deionization, restriking of the arc is minimized, improving overall reliability and safety. The controlled arc chamber allows for a smaller and more compact construction, suitable for medium and high voltage applications. So these are several advantages of cross-jet explosion pot oil circuit breaker. Explain disadvantages of cross-jet explosion pot oil circuit breaker. So the design includes a cross-jet chamber, arc control devices, and nozzles, making it mechanically more complicated than plain explosion pot oil circuit breakers. This increases the manufacturing and maintenance difficulties. Now, because of the mechanical parts and narrow type of nozzles, frequent inspections and cleaning are required to prevent carbon deposits and blockages. Therefore, maintenance cost and downtime are higher. Cross-jet breakers are not suitable for very high voltage applications as the arc control depends mainly on oil pressure and chamber design. They are mostly used in a medium voltage transmission line voltages ranges up to 220 kilovolts. Although carbonization of oil can be reduced compared to the plain pot oil circuit breakers, still, due to the repeated arcing within the pot, leading to contamination and reduced dielectric strength. Since oil still is in use as the arc quenching medium, there remains a risk of fire or explosion in case of heavy faults. Despite being more compact than plain pot types, it is still bulkier than modern SF6 or vacuum circuit breakers, which limits its use in the modern switchgear. The operating time is slower compared to vacuum or SF6 type of circuit breakers. So these are several disadvantages of cross-jet explosion pot oil circuit breaker. Explain construction of self-compensated explosion pot oil circuit breaker with the figure. So in this type of circuit breaker, principles of plain explosion pot type and cross-jet explosion pot type, both type of circuit breakers are combined together. Top portion of the circuit breaker is similar to the cross-jet explosion pot, in which there are arc splitters or there are 3 arc splitters. So 2 lateral orifices are made with the help of these 3 arc splitters. So which increases the length of the arc and cools it properly. Lower part is similar to the plain explosion pot type, and a moving contact is here and vents are created along with a strong steel tank filled with the transformer oil, which acts as both arc quenching medium as well as insulating medium. A small chamber made up of insulating material made up of porcelain or bakelite consists of or is placed inside the tank in which the transformer oils are placed. The fixed and moving contacts are kept in the closed shell. This is the fixed contact, and here it is a moving contact. Both are fixed like together in this manner during the normal operating condition and in the closed shell of the insulating material. These contacts are made up of copper or copper alloys usually. The pot is provided with small gas vents or openings to control the escape of the gas here. The vents are self-compensating, meaning they automatically adjust the gas pressure according to the fault current magnitude. The arc energy produces high pressure and hydrogen gas inside the pot. The design of arc control mechanism ensures that the gas flow and pressure are automatically balanced, that is self-compensated, neither too weak nor too strong depending on the arc intensity. So this is how the construction of the explosion pot types oil circuit breaker can be explained properly with the necessary figure. Explain working of self-compensated explosion pot oil circuit breaker. So when this breaker is in the closed position, that is in normal condition, the fixed and moving contacts are closed and current flows normally through them. The explosion pot and surrounding oil remains at normal pressure and temperature condition. Now in this type of circuit breaker, the principle of plain explosion pot type and cross-jet explosion pot type of circuit breakers are combined together. As a result, this type of circuit breaker works satisfactorily with the less value of the fault current as well as with the high value of the fault current. Now when a fault, that is short circuit or overload occurs, the protective relay operates and sends a trip signal to the breaker. As the contacts separate, the arc is formed between them inside the explosion pot, that is in the arc chamber filled with the oil. The intense heat of this arc causes a small quantity of the surrounding oil to vaporize, producing hydrogen gas and oil vapors. The hydrogen gas produced has very high pressure and excellent cooling properties. The design of the pot ensures that these gases are confined and directed along with the arc path across this, like this, along the arc path. The pressure of the gas depends on the fault current magnitude. The rate of the production of the gas is high when the fault current is more, and the device works as the cross-jet explosion pot. Arc is quenched when the arc crosses first or the second arc splitters provided. When the fault current is less, the pressure developed is less, so the arc is not quenched due to the cross-jet explosion pot and the moving contact reaches to the lower chamber pot. The lower chamber almost closed. When the moving contact comes out of the chamber, arc is quantified due to the rapid flow of the gas and oil from the chamber throat. This automatic adjustment of pressure is called the self-compensation. The high pressure hydrogen gas flows rapidly across the arc path. This cross-blast action cools the arc and removes ionized particles, increasing the dielectric strength of the medium. Now, as the current passes through the natural current zero instance, the gas pressure and deionization prevent the arc from restriking again. Hence, the arc is completely extinguished. Now, after the arc extinction, the gas pressure inside the pot drops back to the normal condition as the gas escapes through the vents or holes or ports. The oil displaced by the explosion flows back into the pot again, ready for the next operation. The breaker can be closed then again or reclosed once the fault is cleared. So this is how the working of self-compensated explosion pot oil circuit breaker. Explain advantages of self-compensated explosion pot oil circuit breaker. So the most important feature is that the pressure developed inside the explosion pod automatically adjusts according to the magnitude of the fault current. This makes the breaker self-regulating and efficient under all the fault conditions. Due to the automatic pressure regulation, the arc is extinguished quickly and reliably, improving the braking capacity of the breaker. Now the arc is confined within a small explosion pod, so only a small quantity of oil is required for the arc extinction. This reduces the size, weight and cost of the breaker. Since the main tank oil is not directly exposed to the arc, it reduces the carbon formation, sludge formation and frequent oil replacement, leading to longer service duration. The breaker has fewer moving parts and experiences less oil contamination, leading to lower maintenance costs and longer intervals between services. The breaker has a compact design and is economical for medium voltage applications. Since the pod confines the arc and gases effectively, there is less risk of explosion or fire, enhancing operational safety. There is less chance of arc destroying due to the strong deionization of gases. So these are several advantages of self-compensated explosion pod oil circuit breaker. Explain disadvantages of self-compensated explosion pod oil circuit breaker. So the design includes special valves, vents and a pressure regulating explosion pod, making it mechanically more complex than plain or cross-jet types of oil circuit breaker. This increases the manufacturing cost and makes assembly and repair more difficult. The narrow gas vents and valves can get clogged by the carbon particles or oil sludge over the time. So regular cleaning and inspections are necessary to maintain proper operation, increasing maintenance effort. Although reduced compared to the other oil circuit breakers, some oil still decomposes during the arcing. This leads to carbonization, moisture absorption and gradual reduction in dielectric strength, requiring periodic oil replacement. Now since the oil is still used as the arc quenching medium, there is always a risk of fire or explosion under the severe fault condition. These breakers are mainly suitable for medium voltage applications, that is up to 220 kV in transmission line levels. Even though it uses less oil than plain oil circuit breakers or plain explosion pod oil circuit breakers, it is still bulkier and heavier compared to the modern vacuum or SF6 type of circuit breakers, which limits its use in the compact substations. The mechanical operation of contacts and the dependence on gas pressure buildup make it slower in the operation compared to the modern fast-acting breakers. So these are several disadvantages or limitations of self-compensated explosion pod oil circuit breaker. Explain construction of forced blast oil circuit breaker with a figure. So in this, a strong steel tank that contains transformer oil which serves as both insulating and arc quenching medium. It supports internal parts and provides oil reservoir and cooling volume for the arc quenching. Fixed contact, here it is. Fixed contact is rigidly mounted inside the tank and moving contact is attached to the operating mechanism. This is attached to the operating mechanism. These contacts are made up of copper or copper alloys. A piston or cylinder or plunger assembly is immersed in the oil. Now when the breaker opens, the piston is driven by a recharged gas charge or a mechanical spring or a fast movement of the contact itself to force oil through a nozzle towards the arc. So when this contact separates and this is the opening from where the oil immersed. This is the characteristic forced blast element, means the blast pressure is provided independently of the arc itself due to this piston arrangement, piston movement available here. This piston moves in downward direction. These are interlinked with together. This moving contact is separate out and this piston goes downward. So oil flows in this direction towards the arc. A-shaped passage or nozzle that converts piston motion into the high-speed jet of oil directed across the gap where the arc forms. Nozzle geometry contracts the oil flow and creates strong dielectric strength or recovery across the arc path. Now, after the oil jet drives the arc is elongated and put inside the arc splitter structure, that is a metallic plates or insulating barriers connected or the constructed to split the arc or elongate the arc, where oil vapor and decomposed gases help extinguish the arc. Porcelain or epoxy insulator supports the live parts and isolate them from the grounded element. External bushings are also provided for the connection purposes for the transmission line or the bus bars. The mechanical linkages, springs, and tracking devices that move the moving contact and simultaneously actuate the blast piston. This is designed for rapid, reliable action and for being charged or reset between the operations. In some designs, a small gas chamber, either of air or of nitrogen, is used to store energy that drives the piston quickly to produce the blast. Drain, breather, level indicator and filters are also provided to maintain the oil condition and allow servicing. Vents or pressure relief valve or devices are provided to safely release the excessive pressure generated during the interruptions. So this is the basic constructional details of forced blast oil circuit breaker, and the figure is shown in this like this. A simple construction here the supporting structures or operating mechanism is not shown in the figure. It is just a basic figure that you have to draw when answering examination.
Explain working of force blast oil circuit breaker. So in the force blast circuit breaker, the pressure is generated externally with the help of another operating mechanism. This type of circuit breaker is also called the impulse type circuit breaker. The force blast oil circuit breaker operates on the principle of the forcing a high velocity jet of oil through the arc region by mechanical or pneumatic pressure to quench the arc formed by the contact separation, means when the contacts are separate, the arc struck in between. During the normal condition, the fixed and moving contacts remain in touch like this, allowing the normal load current to pass through the breaker contacts. The oil acts as both an insulating medium as well as the arc quenching or say cooling medium, filling the tank of oil completely around the contacts. Now when a fault occurs, the protection relay sends a trip signal to the operating mechanism. The mechanical energy stored in the spring or the compressed air chamber drives the piston in downward motion. As the moving contact begins to separate from the fixed contact, an arc is formed between the contacts due to the ionization of the oil. This arc starts to heat and decompose the surrounding oil and produces the gases like hydrogen and hydrocarbons. Simultaneously, the piston or blast pump forces the oil under the high pressure through a nozzle directly across the arc path. The high velocity oil jet blows the ionized gases away from the arc zone, cools the arc by absorbing the heat, lengthening the arc and splitting the arc into smaller sections with the help of arc splitters, and increases the dielectric strength between the contacts. The force blast of the oil quickly deionizes the medium and restores the insulation between the contacts. Now when the current passes through a natural current zero instance, the arc cannot restrike due to the removal of the ionized particles or ionized gases, strong oil flow and rapid recovery of dielectric strength. Now as the rate of rise of recovery of the dielectric strength is high as compared to the restriking instant of the voltage, the arc does not restrike again. The circuit is now completely open. The decomposed gases and hot oil move to the upper part of the tank and are cooled now. Pressure vents release any excess gas pressure into the atmosphere safely. Now the breaker remains open until it is manually or automatically reclosed. So this is the simple working of forced blast oil circuit breaker. In this, the operating mechanism connected with the moving contact and the pistons are interlocked. Whenever this moves in outward direction, this moves in the downward direction. So these are the interlinking between the contacts and the piston arrangement. So this is a simple working of the forced blast oil circuit breaker.
State the advantages of forced blast oil circuit breaker. So arc extension is faster and more reliable than in plain or self-blast types. Second, since oil pressure is created mechanically or pneumatically, the interruption process does not depend on the fault current size or the magnitude of the fault current. Now it can interrupt large fault currents in high voltage system efficiently due to the powerful arc quenching action due to the external pressurized force. It requires less oil compared to bulk oil circuit breaker because the blast mechanism improves the cooling and insulation effect of the oil. The smaller tank size and less oil volume make the breaker more compact and lighter. The forced blast mechanism allows multiple interruptions without significant deterioration of the quality. Effective for high voltage and high capacity installation, generally about 220 kV or more. It requires less maintenance. So these are several advantages of forced blast oil circuit breaker. State the disadvantages of forced blast oil circuit breaker. So it includes pistons, pumps, nozzles and pressure chambers etc., making the design more complicated than the plain or self-blast type oil circuit breakers. Mechanical or hydraulic parts require precise alignment and periodic maintenance. The forced oil system relies on the tight seals and pressure lines, so leaks or pump malfunctions can affect its reliability. The high-speed oil blast and gas release produce considerable noise during the interruption process. It needs an external compressor or hydraulic drive to build up oil pressure before the operation, which increases the system complexity. Although oil quantity is reduced, flammable oil is still used, so there remains a risk of fire or explosion under severe fault conditions. After a major fault operation, the oil may need filtering or replacement, delaying re-energization of the breaker. Compared to SF6 or vacuum circuit breakers, it is lighter, larger and heavier. The additional components increase the manufacturing and installation cost. So these are several disadvantages of forced blast oil circuit breaker.
Explain need of low oil content circuit breaker. So self-blast or forced blast etc. type, we are called this type of breaker as the bulk oil content type circuit breaker, as the quantity of the oil used is very much. The amount of oil required increases when the voltage level increases. For example, 230 liters of oil is needed at 11 kV, while 1800 liters are required at 66 kV, and about 36,370 liters of oil is required for the voltage of 220 kV transformers or the circuit breakers. Thus, when the voltage level becomes 6 times, that is 66 by 11 is 6 times, the quantity of the oil becomes 7.8 times, that is 1800 divided by 230 liters, that is 7.8 times. Now, but when the voltage level becomes 20 times, that is 220 kV as compared with the 11 kV, that is 20, the oil required becomes 158 times, that is 36,370 divided by 230 is equal to 158. Thus, for the high voltage circuit breakers, large quantity of the oil is required, so the size of the circuit breaker becomes large and becomes costly. Possibility of fire is increased and the maintenance is also increased. Now, only 10% of this oil is required to quench the arc, while the remaining quantity of the oil is required for the insulation purposes. Now, if the arrangement of the insulation is done,
by the another way, that is using the solid insulation, that is porcelain or bakelite material, or say epoxy resin instead of using oil. The size of the circuit breaker can be decreased too much and the quantity of the oil also decreases. A low oil content circuit breaker is needed as an improvement over the bulk oil circuit breaker, which uses a large amount of the quantity of the oil for both insulation as well as arc extinction purposes, leading the risk of fire, explosion and frequent maintenance due to the oil deterioration. In contrast, the low oil circuit breaker uses less oil, confined only to the arc chamber for quenching, while solid insulation handles the rest. This results in a safer, more compact and economical design with reduced oil replacement, lower risk of fire and easier installation and maintenance. Hence, low oil circuit breakers provide greater efficiency and reliability compared to the bulky and high maintenance bulk oil circuit breakers. So these are some points to consider the need of low oil content circuit breaker. Explain construction of low oil content circuit breaker, or say minimum oil content circuit breaker with figure. So in this, here it is. This is the top chamber provided. This middle one is the arc chamber or say circuit interrupting chamber, and this last is the supporting chamber. This is the mechanical linkage or operating lever mechanism. This is the moving contact, and here it is the fixed contact which is mounted with one terminal here. This is the drain cock to drain out the oil from the circuit interrupting chamber. This is the separator or say the plate of the bifurcation from the supporting chamber to the circuit interrupting chamber, and this is the drain cock from where the supporting chamber oil can be drained out. So now the top chamber is a small chamber and it kept above the circuit interrupting chamber or say circuit breaking chamber. This chamber provides the space to the oil of the circuit breaker chamber to expand. A separator is provided in this. This removes the sludge produced due to the arc by the centrifugal action. Now second most important thing in this is the interrupting unit or say arc chamber. It is the main oil filled chamber where the arc is formed and extinguished. It contains fixed and moving contacts enclosed in a small oil filled compartment known as the arc pot or interrupter pot or say arc chamber. The quantity of the oil here is just sufficient for the arc quenching, not for the full insulation purposes. Fixed contact is mounted at one end of the interrupter chamber and moving contact is operated by the mechanism to make or break the circuit. The contacts are made of copper alloy. The operating rod or mechanical linkage connects to the moving contact to open or close the breaker. Each pole is enclosed in a small metal tank filled with the minimum quantity of the oil around the contacts. In some designs, each phase has its own separate interrupting chamber mounted on a common frame. The solid insulating materials such as porcelain, bakelite or epoxy resin are used to insulate the live parts and support them mechanically. Porcelain bushings provide the connection points for the incoming and outgoing conductors and maintain the insulation between the live parts and the grounded tanks. The turbulator is the arc control device. Oil impregnated fiber plate is kept in this. This is positioned such that vent line is formed on one side of the arc. This vent side, this is the separator. The vent line is formed on one side of the arc and on the other side of the arc or the plate the oil pocket line is formed. To enhance the arc extinction, arc control devices like nozzles, vents or arc splitters are provided inside the arc interrupting chamber. This directs the high speed oil jet flow along the arc path, cooling it and deionizing the oil or say charged particles rapidly. A pressure vent or the gas escape duct is also provided to release the gases here. This is the the gas vent. This. During the arc interruption, preventing the overpressure inside the chamber. The supporting chamber of the bottom part is the post of the porcelain kept on the chamber of the metal. Oil is filled in this. This oil is not in direct contact with the oil in the upper chamber. This oil works as the insulation. So this is the constructional information of minimum oil contained circuit breaker. Explain working of low oil contained circuit breaker. So during the normal operating condition, the fixed and moving contacts remain in touch, allowing the normal load current or fault current to pass through the breaker. The oil inside the interrupter cord surrounds the contacts, acting as an insulating medium only. Now, when a fault occurs, the protection relay sends a trip signal to the breaker's operating mechanism. The mechanism quickly drives the moving contact away from the fixed contact, initiating arc formation between them in the arc chamber. Now, moving contact is hollow and the turbulator is the arc controlling device. There are radial and axial vanes in the turbulator. These radial vanes is useful to interrupt the heavy fault currents like cross-jet explosion pot, and the axial vane is used to interrupt the low value of the current or the fault current like the plain explosion pot. Now, as the contacts separate and electric arc is struck in between them, inside the small oil chamber, the high temperature of the arc causes decomposition of the oil surrounding and causes the gas production, mainly hydrogen and hydrocarbon gases. The gas pressure and oil circulation inside the arc chamber increases rapidly. The high velocity gas bubbles and oil flow are directed through rapidly or specialized design nozzles or vents across the arc. This blows away the ionized particles, cools the arc and lengthens the arc path, reducing or say deionizing the arc and reducing its conductivity. Now, when the current passes through its natural current zero instant, the dielectric strength between the contacts recovers rapidly and the arc is extinguished. After the interruption, the gas and the vapor bubbles move to the top chamber and the oil cools and regains the insulation properties back again. These pressure vents release any excess gas pressure to avoid damage to the enclosure or the breaker. The breaker remains open, completely isolating the faulty part from the healthy one, and it remains in open condition unless and until it is closed manually or automatically by the operator itself. So this is the simplest type of working of minimum oil content circuit breaker. State the advantages of low oil content circuit breaker. So it uses only a small quantity of oil, minimizing the danger of fire or explosion caused by the gas pressure during the arcing period. The reduced oil volume and smaller tank make the breaker more compact, lighter and easier to install compared to bulk oil circuit breakers. Since less oil is used, carbonization and contamination after the arc interruption are much less, leading to less frequent oil replacement and easier servicing. The arc is confined to a small, specially designed chamber where pressure and cooling are more effectively controlled, ensuring faster and reliable arc extinction. Only small quantity of oil near the contact is affected by the arc, so overall oil life is longer. Due to the smaller oil volume, oil leakage and disposal problems are minimized, making it safer for the environment. Effective and reliable for medium to high voltage applications where safety and compactness are important. So these are several points of advantages of low oil content circuit breaker. State the disadvantages of low oil content circuit breaker or say minimum oil content circuit breaker. So the interrupter unit is more mechanically complicated than that of a bulk oil circuit breaker due to the arc control devices and compact insulation arrangements. The use of the solid insulation materials such as porcelain, epoxy, bakelite, etc. and a special arc control chambers increases the manufacturing cost. Now, because of the oil volume is very small, heat dissipation is limited, which can restrict the number of Arc occurs in a confined chamber, so the decomposed oil vapors and carbon particles can contaminate the limited oil faster, affecting the dielectric strength of the breaker. Though less frequent, maintenance of minimum oil circuit breakers needs careful cleaning and refilling of the oil to ensure proper insulation and arc quenching in the breaker. Minimum oil circuit breakers are usually used up to 132 kV. For higher voltages, SF6 or vacuum circuit breakers are preferred due to the better insulation and compactness. In confined oil chambers, pressure can rise sharply during heavy fault currents, requiring effective pressure relief arrangements. So these are several disadvantages of minimum oil content circuit breaker. State important characteristics of minimum oil circuit breaker. So less quantity of oil is used for quenching. The duration of the arc is 1 cycle to 2 cycle, that is 50 to 100 milliseconds. There is less wear on the contacts due to arcing. So wear and tear on the contacts due to this arcing is very less in case of minimum oil circuit breaker. There is no loss of the quenching medium. The quenching chamber and the mechanism are separate and less attention is required for the operation. So these are some important characteristics of minimum oil circuit breaker, due to which it is highly used in the case of industry and substation as well as transmission network and distribution network.